Hi, Assalamualaikum. My name is Faris bin Marshidan. So today I want to share with you about my task 1 implementation of proportional controller for our lab 5 with my group mate is Jeevan doing the part 2. So firstly, we are going to do the motor speed with proportional controller. So we go to the MATLAB, and this is my simulation at the simuli. So we got two transfer function here, and this one is real, this one is real one, and we add one gain before the transfer function. And how to do this lab is we just change the value of the gain. So here we ask to do the 0.5, 3 and 5. So here we go the 0.5 first, we apply here, we okay, and we must check the step time is 0, initial value is 0, final value 1, sample time is 0.001. okay, then we go to the stop time, we check is 1, so we run it. Done. Then we go to the comma window, we put the coding to get the graph and the data for this one. So the first one we name it as a K1. So K1, safety, and if we want to get the graph, we just put plot x t k1, enter. And then we get the graph here for 0.5 dB controller, proportional controller. So we edit the legend here. The blue one is input, the red one is the real, the yellow one is the real one. So here we have to plot the real one value. So we check the peak value of the real one graph, and here we find the final value to find the TR, TP, TS value for this graph, and then we plot it. Firstly, for find TR here, we must times 0.1 times the final value here. This one is final value, so we mark it as a here. Final value, this is final value, and then this is a peak value, this is a TR. We can find TR between 0.9 times final value and 0.1 times by final value. Then we can get the TR. So the TP is the value of the peak value, TS is the value that nearby the steady state condition. So here, if we check the steady state condition, they must be around here. for the TS value. So here that we got the totally graph that we want. We put the topic here on the headline, motor speed with 0.5 dB, the y value is speed, the x is time. So this is a TR 0.1 times by the final value 1 is here, and 0.9, and we get the value of the TR. And then if we want to get the TS, firstly we must check twice, because 0.98 is so near with the steady state condition, and 1.02 also near the steady state condition. We must check 2, and we have to do the straight line here to check it if is near the steady state or steady state condition or not. And then this is the TP. So that's all for the plotting graph. Thank you. And then we go to the assessment part for the task 1. So the first question is, from your observation, what is the difference between result and with or without proportional gain? So my observation is the result with the proportional gain is too different compared to the result with the proportional gain, because proportional gain controller change the result value. For example, for the time rise, for the rise time, the overshoot is increased, and steady state error also decrease and reduce the value. For the previous slide that we did, we do not use the proportional gain, and we get the value of the percentage overshoot and steady state error almost the same for the 3 different input. For this slide, we can see the major different value we get using the proportional gain. So the next question is, how significant result obtained using different proportional gain value? So like we see from this table, the 3 different value for proportional gain, we can see the 0.5 input result for percentage overshoot is greater than 100, and ESS is in positive value. Next, for 3 input result, we can see major difference for percentage OS and ES value, with the previous one of the ES is in negative. We can see the higher value of the input for proportional gain, the higher percentage of overshoot and steady state error is decreasing. So my conclusion is, when the value of the input is higher, the percentage of S also higher, and the steady state error lower, decreasing, and in the negative value. So this is how to do the task 1 from me, and thank you. We going through to the task 2 with Jeevan. Thank you.
Good day, madam. I'm Jeevan. Yeah, I'm here to discuss about the task 2 simulations. This is a simulating model for the task 2. By comparing to the task 1, we should remove the gain block and add another additional block, which is the additional pole, to continue with the task 2. And the additional pole is to know the response of the system, and after added the additional block, to save the model, the process to save the model is First, to save the model, press save T, save L5 the block number L5 B1. Because of I already saved the program, I just give a example of how to save the model. Then press CLC clear. Again, to plot the graph, again we type T out. This is because I have already plotted the graph, and that's why it shows like this warning. So clear. This is the example how to plot the graph. We should plot the file number, file name B1. Okay, if you press enter, the graph will pop up. So sorry. Okay, for the first graph I'll show how the this is the example of graph which is without the additional pole. Without additional pole, the graph looks like this. Okay, for the first additional pole, for the first additional pole 1 over 0.112 s plus 1, the graph will be like this. B1. In this graph, we can conclude that there is no final value because of the graph looks like this. The oscillations keep going. So that since there is no final value, then there is no TR value, TS value, ESS, the error and the overshoot. We can only conclude the V peak and the T peak, which is V peak is 1.82554 and the TP is 0.0068. For the second graph, with the additional pole of value of 1 over s plus 50, the graph will look like in this graph we have the final value, so that we can get all the required values which shows in the table. The TR value of this graph is 0.082, the V peak is 0.289727. First of all, the final value of this graph is 0.288518. Okay, then the last graph will look like this. This is the final and the last graph of the task 2 with the additional pole. Value of the value shows 1 over 15s plus 1. The final value of this graph is 1.4287. V peak is 1.42867, and there is the remaining values. TR is equals to 1.1558, TS equals to 2.594, TP is equals to 4.839. So now we take a look at the report. From this task to my experiment, the observation I get is the result with the additional poles are two different compared result without the additional pole, which the graph I shows before showing all the three additional poles graphs. The additional pole controller changes the values. For example, there is no final value for the first additional value, so that there is no value of overshoot, errors, TR and TS. For then the overshoot is decreasing. The overshoot value is decreasing for the remaining two graphs. For the previous lab we did not use the additional pole, and we get the values of all the required elements, and also for the task 1 we have all the required elements. For this task we can see the major difference between task 1 and task 2 in our by adding the additional pole in our simulation or the Simulink model. How the additional poles affect your system? The three different additional values of poles, we can see that the first pole of an input of 1, for the first and second graph the input value is 1, and the third graph is the input value 1.5. We can see that for the first pole with an input of 1, there is no overshoot and ESS value since there is no final value. For the next input result, we can see that the major difference for OS, which is 41.9, and the error value is negative 7115. Here we can see that the value is on negative. By referring to this graph, we can conclude that the higher value of when the values are increasing for the input, the higher percentage of overshoot, the overshoot percentages are decreasing, and also the errors are decreasing constantly. Identify system type of each additional poles. For each additional poles, the first one is under damped, second one is over damped, and the third one is critically damped. Finally, by referring to all the graphs, all the graphs, the wave we can get from the graph is more oscillating in the first one and less in the second and the third one for the next ones. Finally, adding the additional poles in the Simulink's model gives us a lot of different and give a major difference in the graph outputs. and find the values of the OS and TR, all the values which asked in the table, and also gives a major difference from task 1 and task 2. That's all from us. Thank you.